Hi again, it's Ryan. Well, I promised you guys a video of an SX-64, and here it is. Now, I've already had to do some work on this. It mostly works now, but when I got it, the drive didn't work. Now, that was a really interesting repair, so I think I'll do another video after this and kind of walk you through the repair process using some of the photos that I took at the time. But right now, the problem that it has, and I think this is the only other problem that it has, is the sound. Now, I've got a program here that it's supposed to do a musical scale, and it's based on one of the programs out of the SX-64 owner's guide. It's hooked up at the moment to a 1702 that I know has good sound. So I'm going to run this, and what you're going to hear is very little of anything, frankly. But we're getting no sound at all coming from the monitor, from the 1702, and very, very quiet sound coming from the SX. So I'm going to run this program, and then I'm going to put the mic over closer to the speakers so you can hear what's going on. And I'm going to open this door. This top control here is the volume control, and right now it's about in the middle. So I'll adjust that up and down so you can hear that as well. Alright, here we go. I don't know if you can hear that or not. Now this is with the volume up all the way. It doesn't go any higher. If we turn it down to kind of about a mid-level volume, you can't hear anything except that occasional pop. Now, odds are there's one of two things that's causing this. It's either the SID chip going bad, or it might be a capacitor issue. So what we're going to do is take this thing apart and start investigating, and we'll see if we can narrow down the problem and fix it. When it comes to disassembly, the SX is a bit trickier than a regular 64. See these side pieces here? These aren't just decorative. They conceal the screws that hold the top and bottom parts of the case onto the inner skeleton, the inner frame. So we have to pull these. It's not hard. You simply remove screws that hold each of them in and slide the back. So once those are off, you can see that the top part is held on by 3 screws on the top, and the bottom held on by 3 screws on the bottom. So we just need to remove these on both sides. Okay. Well, here's the inside. Let me point out a few things here. We've got the CRT and all of its circuitry over here. There's the speaker, obviously. We've got the plastic storage bin here, and you can see the floppy drive underneath it. Cartridge port here. We've got this board here is the drive controller. Power board back here. And this board here is the main motherboard. And let me flip this up and see if you can see this. The chip that we need to get to, the SID, is right here. Now, luckily, that's pretty close to the top of the board. So, I think we can probably test that and replace it if necessary without taking this board out. At least I'm hoping we can test it and replace it if necessary without taking the board out. Okay, change of plan. Instead of trying to test and fix the SID, which is reachable, I think, with the card in the unit, I'm going to go ahead and take it out, and then that way I can go ahead and change the capacitors while I've got it out. Now, to do that, this board is held in with 3 little plastic connectors here. Now, these are, you've got like a sleeve, and then there's a pin that goes into it, and as it goes in, it pushes out on the outside of the sleeve. It's kind of hard to see here with it in the unit and the camera the way it's set up. I'll give you a good look once we get them out. But the easiest way to get those out at least I've found, is to push in the pin and then the little sleeve will also pop out. And I'm trying to be very, very careful so I don't break these things. Okay. So here's the sleeve. If you can see that, the pin would go in this way and push those little prongs apart, and that's what holds it in. You see if I try to demonstrate. So it would go in like that. So we just need to do that on all 3 of these connectors. Very carefully. That one came out and brought the sleeve with it. That one did too. I'm going to go ahead and pull these connectors off. There's one. There's 2. And now, a lot of tight clearances here. There's also, right here, a connector that's pushed together. Okay, there was another one of those black pegs holding this board in over here, so I went ahead and removed that and pulled this board free. You can see it's loose now. I pulled it free of the connector here. I didn't put that on video because my head was in the way. Now, the board should come free, but the problem is we've got some wires down here that are catching on a couple of things here. So I think what I'm going to do is unscrew this back that holds all the power components, and then just let that come out a little bit, and then that should let me get in there to get this free without having to put any undue stress on the board. That's easy enough to do. Just a couple more screws. Off, and now we can pull these wires off. And there we go. So, well, none of the capacitors look bad. So I'm going to guess that the problem is actually just the SID chip failing. So I'm going to set this off to the side for a minute, and we'll deal with the SID. Okay, well, I had this opened up. I thought I would go ahead and pull the I/O board and replace the couple of capacitors that are on here. You can see it's a fairly simple board. You've got the two 6526s there. Both of these manufactured in week 35 of 1984. It's really a fairly simple board. And so what I'm going to do with this one is, you can see that there's just a ribbon cable that attaches it over here. So I will probably either pull this out, or maybe I'll just flip this, leave it attached and flip the board over and just replace it, because there's only two caps and it's not that hard to move this thing around and get to the back side. So I think I'll just leave it attached. One thing I will note, that if you start taking things apart, for instance, I took off the cartridge port. I needed to in order to get this out. So what these are just connected with this ribbon cable, and you'll notice that on one end you've got this red wire. The red wire here corresponds to pin 1 on the connector. So if we look here, we've got another ribbon cable, red wire, and if you look on the circuit board, you probably can't see it on camera, but it's labeled for pin 1. Okay. So that way you always know how to get your ribbon cables back on, because there's always going to be a colored index wire on one end of the ribbon that's going to indicate pin 1. Okay, I know somebody in the comments is going to complain that I switched out the SID chip without doing diagnostics on it. So I'm going to do what I can do here. Now, I don't have an oscilloscope. I do have a logic probe, but that's not as effective on the SID as you might think, because there's an analog component there. But what I can test is we should have 12 volts coming into the SID on pin 28. Now, if we look at the chip, got this little mark here, okay? That's indicating that this pin here is pin 1. So if we were to count, we're going to go from pin 1 to pin 14 and pin 15 to pin 28. So we should have 12 volts on pin 28. So let's take a look here. I'm going to back this up a little bit so that you can also see the multimeter in the shot. So I've got my negative lead touching over on the case of the SX for the ground, and I'll touch here on pin 28, and we've got 11.92. So that's pretty close to 12. So that's fine. We should also have 5 volts coming off of pin 25. So we'll just 28, 27, 26, 25. And I've got 4.95. So that's good. So there's plenty of power coming in. It really seems like this is just a bad SID. Okay, so what I'm going to do next is I'm going to replace all the capacitors on the main board and on the I/O board, and I'll do that off camera, and then I'll swap out the SID. Now, on the off chance that it was a capacitor problem and not a problem with the SID, I'll keep the SID, and when I get one of my bread bins fully tested and working, I'll stick this SID in one of those and just make absolutely certain that it's faulty. But I know, because I just tested it, that I've got good power coming into the SID. So I know that if I put another SID in here, I'm not going to fry it. Okay, I'm not going to damage whatever new chip that I put in here. If I hadn't tested that, and maybe I was getting an over voltage on this SID, which may have caused the problem, if I'd put a new SID in there, I could fry the other chip too. But it's been tested, voltages are good, so I'm fine to put in a new SID. Okay. So I'm going to go ahead and do the caps, and then I'll turn the video back on when I'm ready to swap the SID. Alright, so the board has been recapped, and now it's time to swap out the SID. So our SID is right here. Now, I would love to have one of those nice little chip pullers, but I don't have one of those right now. So I'll use this. It works pretty well. You just have to be kind of careful that you don't bend the pins. Helps a lot when you've got a good socket too. That's one of the good things about the SX, is all the main chips are socketed. So I'm being super careful here because I don't want to mess up to this chip. Okay, here she is. So I'm going to put this aside, and I've got another bread bin that I'm working on, and when that one is all up and working, I'm going to stick that one in and just make sure that it's faulty. Okay, now let's replace it. Now I'm not going to replace it with another SID. what I have here, and this is from Commodore Forever, what I have is a SwinSID Nano. Okay. So this is a modern SID replacement. Looks pretty sweet. Now you'll notice there is right here the little dimple that tells you your alignment dimple. So we're going to go on like this. And it's just going to slide right in. I'm going to be very careful here. All right. So there we are. I want to say just a little bit about the Nano SwinSID and why I picked it. First is the cost. The Nano is, I think, $21 or $22 from Commodore Forever. And, you know, it may not perfectly reproduce the sounds of a SID, but let's be honest, I'm not going to be playing games on this SX. Okay? I don't need really high quality, perfect sound reproduction out of this thing. And at $21, $22, this is a great option for the SID, or for the SX, to give it some sound. And it'll do everything I need it to do. Now, there are a couple of limitations. The Nano, unlike the full-blown SwinSID and the FPGA SID and the ARM SID and some of the other replacements, does not handle mice, and it doesn't handle paddles. So whereas the original SID controlled everything coming in off the joystick ports, whether it was a joystick, it was a paddle, it was a mouse, whatever, all that went through the SID. The Nano has support for joysticks, but not for a mouse, not for game paddles. I don't really care about game paddles. I haven't used a game paddle since, geez, I had an Atari 2600 back in the 80s. So that's not an issue. As far as the mouse, with this tiny little screen, I don't really think using a mouse is all that useful anyway, so I don't really care. Now, having the joysticks is nice, so but not having support for paddles or a mouse for this is not an issue. If I needed to replace a SID in a regular 64, or I need it in a Breadbin or a 64C, or if I needed to replace it in a 128 and maybe I was thinking I was going to be running GEOS or something, then yeah, I probably would make a different choice and get a replacement that did support at least the mouse. But for this, at $21, $22, hey, I think this is a great option. Now, one other thing here is, you'll see we've got a jumper here. And there's actually two spots for the jumper, here and here. This is J1, this is J2. Now, if you're going to replace a 6581, you put the jumper on J1. If you're replacing an 8580, you put it on J2. Okay, and that just has to do with the power requirements and the emulation mode, I guess. So I'm replacing a 6581, So it goes on J1, and that's where it came. Okay. So this is replaced. Now, one other thing before I put this back in. You can see here, this is the VIC chip under this huge heatsink. And this is factory. I don't need to put a heatsink on the Nano SwinSID because this is modern. It's not going to run nearly as hot as the original did. But I am going to put a heatsink on the processor. So let's do that real quick, and then we can start reassembling this thing. This is the heatsink I'm going to use. Now, I believe this one came from console5.com, but you can get these lots of different places. They're sold based on the size of the chip that they're meant to sit on. So, for instance, this is the size for the 40-pin chips. And it'll just fit right over there, nice and perfect. Now, if you watched my last video on a bread bin where I heat sinked some of the chips, I used thermal tape. And the advantages of thermal tape is it's not at all messy, and it's easier to remove if you ever want to. For this, I'm going to use thermal glue. And the reason that I'm using the glue on this one is because I think it is less likely that as this thing is moved around a lot, that the heatsink would actually come off. So, before I put this on, I'm going to clean the top of that chip. Make sure I've got a nice clean surface. And this is just some isopropyl alcohol and a Q-tip. Whoa. Now just a bit of glue on the heatsink. Spread this around. Get a nice even coat. Push it down on the chip. And let it sit. And that's all there is to it. So, once this dries, I will start reassembling, and so we'll pick up the video at that point. Well, it's all hooked back up. Let's turn it on and see what happens. Oh, did you hear that beep? Looks good on the 1702. Looks good on the internal monitor. Now I have the same disk in there running the same scale program that I used earlier. Nice. Well, I think we can consider that a successful sound repair. Alright, so we're back up and running. This disc is part of a lot that I just got the other day. that's what burger time sounds like on a repaired SX-64 with a Nano SwinSID. So that's all. Thanks for watching.